First of all, good afternoon, everyone. I'm Hadi Cherkaoui. I'm an apprentice at CM Informatik AG as a platform developer. And today we're going to look at one architectural choice of a small Kubernetes project that I made and what it costs to not use an operator in Kubernetes. For logistical reasons, please skip the questions at the end. And yeah, let's begin. Let me start with what broke. The panel that manages my Minecraft servers was tanking its ticks per second. The fix wasn't hardware. I already tried that. And what I noticed was it was surprising because CPU wasn't idle, server wasn't doing anything, RAM was more than enough, and networking was pretty much empty. Nobody was on the server, and the server was still lagging for no reason. The first instinct, like I said, was throwing a bigger machine at it. Like I said, bigger CPU, had more RAM, better networking, still had the same problem. So I went looking at what the panel was actually doing at the core. The panel was in the runtime of the Minecraft server. Every single thing that the game process was doing, the Minecraft server, was passing through the panel. The panel was acting like a middleman. It was processing each and every standard out string that the server was throwing at it. It was effectively, well, obviously it was the case. Crafty, the panel that I was using as an example, was passing every single byte that the Minecraft server was outputting in its standard out. Now, that usually isn't a problem, but Java processes, Minecraft servers, were sub-processes of the panel. And what Crafty was effectively doing is the thing that costs a lot of performance. So here's the actual line that was costing performance. If you see here, the server out buffer checker reads every byte the standard out output of the Minecraft server. It was attached to the standard out and reading every byte. Now, the read one call looks like it's only calling 1 byte every time, but to be honest, the buffer reader in the backend was fetching 8 kilobytes at a time. It wasn't a single byte every time. There would be a lot of syscalls. But still, in the code, Python was effectively processing each and every byte. Each byte returned a 1-character string. That was the problem, because every time Python processed that single byte, it was holding the GIL. And GIL can't be shared across processes. That means when it's locked, other processes that try to use the GIL just get stalled till this process is done. And the to-do comment even said it. The Crafty team knew this was pretty expensive because even if the Minecraft server wasn't doing anything, logs were getting read the whole time and processed every single time, even across multiple Minecraft servers. That means if multiple Minecraft servers were logging at the same time, if on idle or used, they were effectively stalled because the standard out was locked because it couldn't process the bytes. That was a big problem and also a big reason why it's getting stalled the whole time. Also why the Minecraft servers were tanking its ticks per second. So they were all effectively fighting for the GIL to process their bytes. That's the problem. Here's the alternative I built. What is Anvil? Anvil, effectively from the front, looks like every standard panel. List of servers, you can start, stop them. If you go onto server, we can see that in the demo later, you will see console logs, files, some metrics, all of that. What's important is what happens in the core, in the backend. It's hidden from us, imported for infrastructure. The server that gets made by Anvil is effectively independent of the panel. It runs on its own. Anvil isn't in the middle, just like Crafty, for example. It's not a sub-process, it's effectively its own thing, service running in Kubernetes. Anvil just manages it. It's never in the runtime. Imperative, not an operator, and on purpose. People assume I never heard about operators or didn't want to learn about operators. I mean, it's a big topic, it goes pretty deep, it's a lot. But controller runtime for Go or even the cube builder, I've heard of it, I've learned about it, I was deep in it. I knew what operators were, I knew the reasons to use an operator, but even with that knowledge, I chose to not use one. There is a big reason, multiple big reasons behind it. The next slides will show why I chose about not using operator. So, when do actually operators earn their complexity? Operators are used for one core reason most of the time: autonomous reconciliation between user actions. Now, a canonical example is cert manager. A human doesn't choose for a cert to expire, nor does a human choose to renew it. Cert manager detects automatically if a certificate expires, and then automatically renews it while we are asleep. That's the whole reason. Autonomous. We want that to do that. We want it to always keep our stuff running, our logic, our production environment to keep running, and not even have humans intervene for some small actions like renewing certificates. Now, another example would be etcd member recovery. If a pod dies, you would want it to recover. The operator would notice, hey, the pod is dead. I don't know why it died, but I'll have to spawn a new one, join it to the cluster, and keep it running. The whole reason for an operator is to keep the state it wants, that is effectively wanted by the human. Again, another autonomous example, no human interaction. Anvil's domain is different. Minecraft servers don't expire, nor do they recover themselves. If one crashes, I want to know why it crashed. A Minecraft server crashes for a reason. There's no reason to just get recovered and move on like nothing happened. So there's no loop to silently restart it because it doesn't want it from us. The only events that Anvil processes are human clicks. Starting a server, stopping a server, updating a server, updating the settings, viewing console logs. All of that is human action. There is nothing that happens autonomously in the backend. Nothing. No autonomous events means no reason for an operator. Pretty simple. It's just overhead. With the whole controller runtime and everything, would be a wrapper at the end. I wrote this down before any code. Service start and stop on human demand. Between user actions, there is nothing to reconcile. The reason I wrote this down before I wrote any code was because I wanted to know what I wanted to program. Normally, I would have directly grabbed for the operator. I even thought about it, but like I said, I chose to not choose it because there's no autonomous reconciliation. It wouldn't make sense. It's just a lot of overhead. See, here is the architectural payoff. First of all, you can see in this diagram, the user in his browser goes on the Anvil panel. He interacts with the panel, maybe starting a server, for example. Anvil talks directly to the Kubernetes API. The Kubernetes API then does the logic. It just, for example, if you start a server, in the backend, it just runs a pod. It tells the StatefulSet, I need one replica of the server. Please run it, attach its PVCs, etc., all of that normal Kubernetes stuff. But you can see if the Minecraft player wants to connect, it doesn't go through Anvil. It directly talks to the Kubernetes service, and the Kubernetes service forwards it to the Minecraft server. There is no middleman in between. So that means there's also no runtime path. Server is independent of the panel. This means, in theory, I could kill the panel, updated it, whatever, it could just die for some unknown reason. And the service should stay as is and work as is without any problems. Here's the side-by-side. Same logic, different implementation. On the left side, you can see the crafty known code we already saw before. We know multiple syscalls process every byte, even when the user doesn't want to see the logs. See, in my code, you can see I just pass log parameters to Kubernetes API, tell it, hey, I want these log lines from this pod, this is how many I want, etc. Then the log stream is the effective logic. You can see Tokyo select, that means I spawn another thread. I tell it, if you receive no data, close it. That means don't stall the panel in any way. Just close the connection if you don't see any logs. Next line shows if there's a timeout, so if the Kubernetes API doesn't answer for some reason, also closes the WebSocket connection. Effectively in Kubernetes, if we ask for logs, it's a WebSocket connection. It's the same job, different architectural costs, has, yeah. Now, let's move on. Now I'm going to show you a demo of this exact example I told you about killing a server, killing Anvil, and still being able to join the server. First, we'll need to make a server. Pretty easy. Click on New. Or can you keep it vanilla? Choose the latest version. Keep everything on default. And wait, we still need a name. So then we'll just create it. In the background, it just instantly made its Kubernetes resources. Kubernetes is, in most cases, the API answers pretty fast, so that's why it directly is available. Then we'll just start the server. This should be pretty fast, takes about a minute. It's a vanilla server. Still needs to download the files, etc. Like you'll see the logs instantly. That's directly streamed from the Kubernetes API. Nothing that gets read, processed, or anything. API just sends, we just display. Oh, like you see, server already created and started. Then we can start the Minecraft client. Give it 1 second. Let's full screen it. We can go multiplayer, direct connection. Let me check if that's the IP. You'll see it directly gets an IP from the Kubernetes load balancer. We see it's the same one, so I can join. So now we see I am on the server, connected that we just made. I can move around, use chat, etc. Normal Minecraft server, like any other, right? Then we'll see in the panel, in the logs, what I just wrote, that I joined, etc. Just like normal. Now, to prove that the server is independent, we'll just go on my cluster. You can see this is the Anvil deployment. To show you, I'll just scale it down, effectively killing Anvil. Now it's scaled down to 0. We can see I won't be able to reach Anvil anymore, right? No available server. Let's get back to Minecraft. And you see, I'm still able to move around, still use chat, like nothing ever happened. Let's switch back. We can close the game also. Let's scale Anvil back up. Give it a sec. See, now Anvil is started. We should be able to just refresh and see the server is back here. It's still running. We can even see that I disconnected. It fetched the latest logs, even though it was down. And yeah, service still runs. You can even stop it, just like anything other. There was proof that the Minecraft server is independent of the panel. It's never in the runtime. See, now to be honest, not using an operator is not always correct. That's obvious. This is why it would be wrong to use the Anvil choice of not using an operator. Workloads would autonomously fail because Anvil isn't doing anything. That means if you have autonomous workloads that could fail and should be recovered, this pattern is obviously not the choice. State that needs to converge between user actions. That means still doing autonomous actions, all of that stuff, Anvil still only depends on human clicks. So if no human clicks happen, nothing autonomously happens. Stuff like replication, auto-scaling, all of that stuff, it's still all autonomous. Third, multi-tenant safety. There's a reason why custom resource definitions exist and the versioning behind them. You wouldn't need to depend on each and every user that uses your operator to just update their manifests if a new version comes out. That's why CRD versioning exists. This has zero versioning. Anvil has no versioning. If it's updates, APIs update. You have to accept it. So that's another reason why to not choose this pattern. So, but at the end, Anvil has none of these requirements or properties in its current scope. That means there's no reason to use an operator. It's only overhead at the end. If this lands wrong for the domain, don't use it. It's a niche. See, the operator pattern at the end is a tool. So the imperative one solves a different problem. Operators most of the time are the correct pattern to use in Kubernetes, but this was just an example to show you why operators are not always the solution. There are solutions that make sense without being an operator. You can see this the repo where Anvil is hosted. It's open source. You can obviously self-host it if you want. Yeah, that would be the end of my presentation. Questions are welcome. I'm happy to answer.